Hey everybody! Okay, the purpose of this video is to get you some instructions on how to do this in-class quiz, because you won't actually be in class, you'll be out of class doing an in-class quiz, which I suppose just makes it a quiz. So anyway, there's some technology involved with this that I want to make sure that you understand. You can read this first part here. Yeah, and this we were hinting at this today. Average rate of change. That's what Phoebe came up with when she said, "Oh, we can figure out you went 200 feet in, I think it was 9.81 seconds. Yeah, 9.81 seconds right there." So, and that was great. That was the distance. I'm going to draw it on here, actually. We're just going to draw the line we drew in class. Let's see, insert shapes. Yeah, so this is the line that we drew in class, and we figured out the slope of that line. And I think if I remember correctly, I believe it was 14 miles an hour. And we had a nice discussion about what that meant. And we visualized two Seans, one going exactly 14 miles an hour and passing the other Sean, starting at rest and then accelerating. And when they came back together again, they will have covered the same distance in the same time, but one did it very differently than the other. And that's kind of where we kind of ended. No, I just lied to you. We did not end there. We then, Angelique brought up, we can get a better estimate of my speed by, let me insert another line. I'm going to use we went from 100, there, that's what we did right there. We went from 100 to 200, then we approximated that slope, and I don't remember what that slope was. We could calculate it pretty quickly, but that's the point of this quiz, is to not have to guess at these slopes, but instead to actually get a better approximation of it using the points we have, and here comes the best part, the points in between the points we have, which is what we don't see yet, but we'll get to that. Okay, so I'm going to pull those lines back off. That's as far as we got. So let's go back to the quiz. All right, it says start by opening the Secant Lines spreadsheet. Okay, so this is back on the same resources page we use all the time. Let me find it. Here's resources, that's not resources. Give me a second here. Let me get to my web page. Thought I was already there. Was not. Rule. Here we go. Rule. All right. So course information, resources page. So if you come into the resources page, it's exactly the same area we were in today, except we're going to use this Secant Line generator link. Let's pop that puppy dog open. And what you're going to see is you see this graph right here, which tells us nothing yet. And the reason it tells us nothing yet is because there's nothing in it yet. We have to tell this how to help us. So what we're going to do is we're going to take the data we got from class. So here's the data we pulled from class. Okay, let's take a look at this. So at 0 feet, I was going 0 miles an hour. Big surprise there. At 25 feet, I was going 3.4. At 50, I was going 4.86. So I'm going to take my time, and this is what you're going to do too on your quiz, and you're going to put these times into your Secant generator. So 0, 3.4, 4.86. I think I can remember that much. 0, 3.4, 4.86. Now some magical stuff is happening over here. Some magical stuff is happening. What Excel is doing is it's taking the points that it can see and coming up with what we discussed in class, the best fitting curve that matches those points. So far we gave it 3 points, and that's the parabola it thinks belongs in those 3 points. And that's fine, except that we have many more points than 3. Let's go get it. 6.07, 6.92. Let's see if I can remember that. 6.07. Whoops, that's the wrong number. 6.07. 6.92, okay, it's taking me a little bit longer time to get down the hill. Notice the parabola starting to change as we enter more points. 7.68, 8.09. 7.68, 8.09, okay, and then we gotta go with 9.16, 9.81. Crap, was that 06 or 16? I just said that and then promptly forgot it. 9.16, there we go. And then 9.81. There we go. And that blue curve right there should look-ish like the curve. Actually, I can show you the curve we made in class. We go back to our class spreadsheet. Let me zoom it out a little bit. Remember this? We did this in class. You can say no, because it was probably a day and a half ago by the time you're watching this. But trend line, we went into more options. We played with the polynomial curve. Boom, right there. That curve right there is the same curve you are seeing right, sorry, too many spreadsheets, right here. That's the same curve you're seeing right here. Okay, hopefully this makes sense. It's the same exact thing. What I've done though is I'm not showing you the actual points anymore. I pulled the points off, so all you're focused on is this smooth curve. So what this curve is, we talked about this in class, this is the map of my distances with respect to my times as I made the journey down the hill. In class, we collected just the points. So we didn't collect this curve, we collected those points, which was cool because that gave us a snapshot of what we were doing. But once we put the curve in, we realized, oh yeah, because it wasn't like I jumped from 0 to 25 feet and then to 50 feet. That would be pretty badass if I had, actually. But I mean, I also would have hurt myself, especially going 14 miles an hour or faster. So watching it, it looked like this, hence the point of this spreadsheet. Okay, so far you've done that much. Okay, thank you very much. Back to the quiz. All right, here we are. We just did number 2. Hopefully you caught up. If you didn't catch up, hit pause on the video right now and get caught up. Although I'm thinking now, I just said hit pause on the video, but if you need to go back and get those times, maybe I'll include the spreadsheet. Now, you know what? Just go back and do it. Go back and watch it again and keep up. Okay, what we're going to do is explore. Yep, on average, as I approach 200. Okay, so look at this sentence. This sentence is important right here. What you're going to do now is explore how fast I was going on average as I approached the 200-foot tape. This is what Angelique was hinting at today when she said, well, what we should really do is slide the first point closer to the 200-foot point. And I said, hell yeah, that's exactly right. And somebody said, what if we go to 175? But unfortunately, it was 9:58 when that person said that, and then class was over, so we didn't have time. So what we're going to do is we're going to set the sheet up to help us do that, and I'm going to let you finish these puppy dogs off. Number 4, I want to clear one thing up before I set you loose. This number 4, I give you a point for this. It says, at what average time did I pass the marker at 200 feet? And then I gave you a hint. I said, look at the value in D9. Okay, this is a little bit confusing, so I want to talk you through it now. So if we look at cell D9, boop, right there, notice how it gives you a bright, that's bright yellow because, let's face it, it's me, 9.74. That is the number of seconds that correlates to this graph at 200 feet. Now, those of you that are astute enough to notice will notice that my data point that I put in was not 9.74, 200. It was 9.81, 200. And some of you might notice and be like, why the hell is that different? And the thing I want you to remember is when we go back to the original data points with their trend curve, we talked about this 2 days ago. You've completely forgotten it, and that's totally fine. Here we go. I want you to take a look at that point and that curve near that point. Let's zoom in on it and see if we can make it a little bit more. Yes, we can. That's actually pretty good if we zoom in. Let's zoom in even further. Oh, that's hypnotic. Look at that. You see where that point is? And you see where that curve is? That curve is not running exactly through that point. And if you look at all the points, you'll notice this is group 150. We knew that one's going to be off. But if you look at all of them, that one looks like it's kind of catching right through the middle. Yay, group 125. But look at group 100 is a little off. And then over here, this one's off a little bit. And then this one's going to be, this one's a little bit low. The other one's a little bit high. And what you're noticing is you're not getting a perfect fitting curve. Oh, this is making me sick. There we go. You're not getting a perfect fitting curve. You're getting, as you all called it in class, a best fitting curve. It's averaging the behavior of all those points. So that explains over here why this is not exactly equal to that. This is the mathematical best approximation of the time it took me to get to 200 feet. That's all that is. That's all that is. It's a smoothing of the data and smoothing it into a perfect parabola, as opposed to ours, which was more of a clunky parabola. It wasn't perfect. This is the mathematical smoothing, if you will. Okay, very, very good, very, very good. Now, the only thing you have left to do, and now I'm not going to do these for you because the whole point of this quiz is to have you do this. We're going to have Excel speed up the process that we were doing in class today. So what it's going to do is it's going to allow you to do what Angelique did when she had us change the line from going from 0 up to 200 to 100 to 200. Now the catch is this. The catch is this. It was easier for us in class to specify it by distance because these are in 25-foot increments, 25, 50, 75, 100, and so forth. The way this sheet is set up is you change the value in this box right here. So for example, I'm just going to put the number 9.74 in that box. And you might think that's a stupid thing to put in that box, but that's okay. Here's why I put that in. That's, if you look at what it's called, it says number of seconds before I cross 200 feet. Remember, the question is, how fast was I going when I hit the 200-foot tape? Not on average through the trip, but when I hit the 200-foot tape. So if I put in 9.74, and that's the approximation of how long the trip took, then what I'm actually getting is, I'm getting, starting when I went 3, 2, 1, go! 0 seconds, ending at 9.74 seconds. And that will end the trip at 200 feet. Now, of course, because we're using approximate mathematics, you'll notice that the y-intercept should be 0, 0, and it's not. It's 0, negative 0.6. That's okay. This is all approximate best fit curve fitting. I'm having a hard time finishing that sentence. Stuff. Thank you. Stuff. It's best fit algebra stuff. Jessica, thank you very much for my color person. I appreciate that. Okay, so now what you do is you can put any number up here you want leading up to 0. Because remember, it's number of seconds before I cross 200 feet. So suppose you want to know how fast I was averaging. Oh, sorry, back up 1 second. I got excited there. Back up. If I start at 9.74 and go to 9, if I go at 0 to 9.74, I was going 14 miles. I'm pointing at the screen. You can't see that. I'll circle it here. So 14 miles per hour is how fast we calculated in class. 21 feet per second, 14 miles per hour. All I'm doing is I'm using Excel to do what it should do, which is speeding up the calculations we did in class today. These calculations, if you remember, took us about 20 minutes at the end of class. Not that they're hard, they're just time consuming. Well, now, if we can do what Angelique said, let's say what would happen if I went 8 seconds before the end. So you see what just happened? The old line looked like this. The new line is steeper, just like Angelique's line was steeper because we slid it over here to about 6 point whatever seconds that was. So what these lines are called, they're called secant lines. Secant lines, if I remember my geometry correctly, I believe it's because they intersect the curve in 2 points. I think that's why they're called secant lines. And eventually, well, we'll get to that in a second on the quiz. So, as we said in class, the idea is to scooch these closer. So you see how that just got scooched a little bit closer? 7.2, that got scooched a little bit closer. So what you're going to do with the remainder of this quiz is you are going to scooch. I want to know, on average, I was going 7 seconds before that time, 5 seconds before that time, 2 seconds. Now this is not, all you're going to do is you're going to put those numbers into that same cell that I was just messing with in the spreadsheet, which is this cell D2 up here. Okay, I won't put one of those in because I'm going to have you do that, but that would just be like changing that to 6 and seeing what would happen, or changing that to 3.14 and seeing what would happen. Okay, you're just changing those numbers and then watching what the speeds are doing. Now, as you get down towards the bottom of the quiz, just an Excel thing. When you get to a half and a tenth and a 1/100th and 1/1000th, be careful. If you try to type that looking just like it does, Excel gets pissed off. It thinks it's a date. So if you're going to put these numbers in, do one of two things. For example, let's suppose I wanted to put 1/3 in. If I wanted to put 1/3 in, don't put 1/3. If you want to put that in, put equals 1/3. Because then it'll treat it as an actual computation. Or put the decimal approximation 0.33333. So you can't put a fraction. The slash bar does not mean a fraction bar or division unless you put an equal sign with it. If you put a slash bar, it means like a date divider, like it would think that was January 3rd or something like that. Actually, I'm curious now. Let's see what it would do. Actually, I'm not. I'm not curious because then you might do it. Don't do that. Equal sign with the slash, or just make them. I think I gave you all fractions. You could just type decimals in if you wanted to. Yes. And then at the very end, you're going to circle how different were the results of these last few calculations. I put that you did. Technically, you're letting Excel do it, but it's taking care of the annoyance for us. And then make sure you get this part. Make sure you do that part at the bottom. Yes, and Jessica is applauding because she teaches calculus, and I think she was pretty excited about this because this is kind of the whole point of Math 251. This is kind of what you do in Math 251. But we're not going to do the rest of Math 251. This is the part I care about, which is being able to approximate a speed at a moment. And when I say at a moment, you can't see me making quotes in the air. And you'll see that. We'll discuss this on Tuesday when I see you again and you turn your quizzes in. All right, and I think that is a 15-minute video. I apologize. That was way longer than I thought it was supposed to be. Maybe my dulcet tones lull you off into a state of concentration, and then you knock this quiz out. So everybody follow where everything was. I gave you the quiz, so I can close this now. You don't see that anymore. This Secant spreadsheet, I'm going to close it down so we can find it again. The Secant spreadsheet is on the website right here, Secant Line Generator. And the data you will need will be in this video, which I will now go upload to YouTube, and you'll have a hyperlink for. All right, rock on. We'll talk to you soon.